What happened? I don't know if this is working. I hope it is. Okay. I'm just going to revise, go over briefly the normal operation. Then we get into the error operation for sliding window protocol. I found my markers, by the way. This was lost. Found it in another lecture room. Okay. The sliding window protocol usually involves a sequence of numbers that are used to be allocated to the frames or packets that are transmitted by the sender. And this is agreed between the sender and the receiver. So if we have a sender and a receiver, can you see that? And if we agree on window size 3, for example, the window size just indicates to the sender what frame numbers and how many frames the sender can send. And usually we use a timeline at both sides. And usually, once we agree on the window size and the modulo, let's say we use modulo 8. Modulo 8 means we're going to be using the same numbers, the numbers from 0 to 8, and when we reach 8 or 0 to 7, and then we go back to using them again and again and again continuously. So this way we only have fairly small numbers to include in the headers. So let me turn this thing off or down. Yeah. Yeah. Whenever the sender then starts sending, based on the window size, what are the frame numbers that sender will send? Start with you.
0, 1, 2.
0, 1, 2. So frame number 0 is sent, number 1 and number 2. Don't forget to say a copy of each frame is kept. So that's frame number 0, frame number 1, frame number 2. Anything else the sender does? It also keeps a timer, starts a timer for frame 0, frame 1, and frame 2. The timer is an alarm that goes off after a long time. Enough time to allow the packet or the frame to be transmitted, for the receiver to process it, and for an acknowledgement to be sent back, maybe multiplied by 10. So the timer will only come in effect if really we never get any acknowledgement for some reason. Maybe if the frame is lost or if the acknowledgement is lost. But don't forget that the sender starts a timer for every frame and sends the frames. And usually there is a window size. Let's say we agreed on window size 3. So normally the sender, here's a window. I have a window that shows the numbers, see? So normally the sender can only see those 3 numbers, 0, 1, and 2. That's why it can only send 0, 1, and 2. And the sender will push the window forward only after receiving an acknowledgement. So it's the acknowledgement that makes this, receiving an acknowledgement makes the sender push the window forward. And then it will show the next few numbers that can be sent. So let's keep that going on the numbers. So the sender starts first at 0. We're starting. It means it can send because the window size is 3. If we had window size 6, then we'd probably be able to send all these frames, 0 all the way to 5. But no, we are now working at this window size 3. Now, if those frames are received perfectly and correctly, each frame, if it's perfect, no errors, and it's in the correct sequence, the receiving machine will not keep it. It will keep nothing. It will only have enough space for 1 frame. Get it, process it. If it's good, send it to the user. If it's bad, discard it. So in the memory that belongs to the data link layer, there's not really much room at the receiver. Just space for 1 frame. All the rest of the frames, even if they arrive, they're kept in the buffer in main memory somewhere, but it's not in the memory allocated to the data link layer. So the data link layer, really, the receiver doesn't need much memory. But of course, the sender needs a good bit of memory because it needs to keep copies of those frames.
What's the name of this process? It's not sliding window.
Sliding window protocol.
Oh, it is.
Okay, we have another name for it. We'll come up to it later. But yeah, this is the protocol. This is how the protocol works. So now, if everything goes well, those frames, 1 at a time, will be sent to our user, who could be maybe they could be downloaded, placed in a file on a hard disk, or music played on the speaker, or video being displayed, whatever it is, or a message, an audio message, maybe communication. But now the receiver will send back a message because the sender will never send anything else unless it receives, okay, go ahead, send me the next group of frames. So we know that the receiver will send back an acknowledgement. And what acknowledgement number will the receiver send back? Did you say 2 or 3? 3, yeah, okay. That means the receiver now, or the sender, received the acknowledgement 3. That means now I can push the trailing edge of the window up until it goes past, until it points at number 3. See, the window now says, hey, these are the numbers you can send. So now the sender is once the acknowledgement is received, okay, if you stop sending messages and texting, once the acknowledgement is received, the sender is gonna delete those copies. We no longer need them because we've already been acknowledged that they have been delivered. And we turn the timers off and we send the next lot of frames. What are the frame numbers that we're gonna send? Go on, put your hand up. What are the frame numbers to send next, please?
6. I mean, 3, 4, 5.
Thank you. There, the window tells you what they are. So we send 3, 4, and 5. What else does the sender do? Keep copy of those 3 frames, 3, 4, and 5, and start a timer for each frame, T3, T4, and T5. Okay, so that's the way things go. Right, and if they all received perfectly, 3, 4, and 5, they'll all be delivered to the user, and we'll get back an acknowledgement. What acknowledgement will we get back?
6.
Acknowledgement 6. The acknowledgement 6 makes the sender remove those copies, turn off those timers, and send the next group of frames. What frame numbers? First, it will move the window forward to number 6. And see, the window now says you can send 6, 7, and 0. But you already know that. So you don't have to really look at the window, but yeah. So we'll send 6, 7, and 0. and we keep copies of 6, 7, and 0. And start the timers. Thank you for 6, 7, and 0. Now we're gonna start having fun now. Right. So this guy sends back acknowledgement. So you got 6, 7, and 0. What acknowledgement should the receiver send back? They're all perfect. 1. But this acknowledgement got lost. We never got it. So what's going to happen next? How is the system going to work? The sender is waiting for acknowledgement. The acknowledgement is never going to get there. The receiver, that's it. There's nothing else coming up, so it's not going to send anything. So what's the system going to do? Any idea? Any idea what's going to happen? The timers will start go off. So now things will go idle, nothing happens, because the sender and the receiver normally after they finish what they're doing, they go sleep. They're waiting for an event. The event is usually if something comes in. If our user says, if I was the sender and my user says, here's a packet, send it. Then I have to send it. But I can't send now. Even if I have lots of packets to send, I can't send them because I've already sent the window size, which is the maximum unacknowledged frames. I must wait for an acknowledgement. So maybe our receiver is busy or something, but no, it's went beyond busy. So now we go sleep until the acknowledgement arrives or the timers start going off. So now the timers, one after the other, will start beeping off. So the sender wakes up, what's wrong? And the operating system will always tell you why you are being awakened. What's the interrupt that's been happening to you? So tell you, timer 6, alarm will start timer 6. You might have few alarms, but when the alarm wakes you up, it also tells you this is alarm 6. And then when number 7 goes off, it starts telling you another interruption. This is timer 7. So once you see timer 6, that means you must take packet 6 and send it again. So the sender starts sending packet number 6 again, because the timer goes off. Stop the timer. Once the timer stops buzzing, turn it off, send frame number 6, and start the timer again for number 6, a new timer. And then immediately number 7 will go off, so we'll send it, and then number 0 go off, we'll send it again. These are the second copies we're sending, second copies. And that's another error that the receiver will get. What's the receiver waiting for? The receiver is waiting on frame number 1, but it's going to get number 6. It's already received number 6. We call that duplicate copy. So that's another error. Remember, we wrote a few errors last week. We said we can have a bit error, we can have an out of sequence error, we can have a lost frame. Now we can have actually a lost acknowledgement, which is this one would be a data frame or information frame, but it can be an acknowledgement frame that got lost, but we can also have duplicate frames. So duplicate frames, we do nothing, we just discard them. What do you do with the duplicate frame? Discard. But you can send back the acknowledgement. You get a frame, that's wrong. We're waiting on 1. You get a 0. You say, sorry guys, I need number 1. So the receiver sends an acknowledgement, and all those frames that it got again, 6, 7, and 0, discard, discard, discard. Why? Because there are duplicate frames. Out of sequence, if you get a 1 that you haven't got before, but it's skipping the correct number. If you're waiting for number 2, but you got 2. If you're waiting for number 1, but you didn't get 1, you got number 2. That's an out of sequence. But if you get ones you already got before, they're duplicate frames. Just discard them and send an acknowledgement. So hopefully this time this acknowledgement is received by the sender and will send the next few frames. So if we get acknowledgement 1, that means we move the sliding window to show number 1, and that says, excuse me, you can send 1, 2, and 3. And that's what we end up sending, frames 1, 2, and 3. And we keep copies of 1, 2, and 3. So between the acknowledgements and the timers, we can solve almost any problem, most problems. There's only one problem cannot be solved. But remember, any problem, it can only be solved by the sender resending the missing or the bad packets or frames. So everything is done by retransmission. So these are the kind of errors that we can handle. And we handle them normally by resending the information. So now, if I send you 4 frames and one of them is lost, who discovers the lost frame? Anybody can think? Who can discover the lost frame? The sender or the receiver? Pardon? The receiver. If I send you frames 1, 2, 3, 4, but number 2 is lost, you get 1, 3, and 4. How does the receiver discover the lost frame? Thank you. How do you know a frame is missing? If I send you 1, 2, 3, 4, but 2 is not there, you receive 1, 3, and 4. We call that, what do we call that? Out of sequence. The receiver will get an out of sequence frame, the wrong sequence. Okay. If I only have 1 frame left, we're sending you all the frames, all the data for a file. You're downloading a file. You got about 1,000 frames. There's only 1 frame left, the last frame. I'm the sender. I send you that lost frame. Even though I should send 4 or 5, the window size says 4, but I have no data. This is the last frame I'm sending you. Excuse me. But that frame is lost. Who discovers that? I send you a frame, but then it disappears in the network. How does the system discover the missing frame? The sender or the receiver? One or two, yeah? Anybody? How does the sender discover it?
It wants to receive acknowledgement from the receiver. Just random those words.
Yeah.
The timer will.
Yeah. So it's the sender who will discover this. If you're sending 1 and only frame, or 2, but they got lost, the 2 of them, or you're only sending 1 frame, and the frame is lost, and there's nothing, the receiver doesn't know. The receiver is asleep. If something arrives, the operating system will wake it up. If nothing arrives, it will not be awakened. So it will never know something. It's like a friend of yours going on a holiday, they send you a letter or postcard from Australia. That postcard got lost. You don't know about it. You didn't know it was being sent. Even if it was, you just wait, but you don't know it is lost. So in this case, if the receiver doesn't receive anything, the receiver will discover it only if, for example, I send you 1, 2, 3, and 1 is lost. So you get number 2. Now the receiver will say, oh, where's number 1? That's when the receiver discovers a lost frame. But if there's only 1 frame left, number 5, I'm sending it to you and it got lost. You're asleep, you're waiting. Nothing will wake you up actually. So the receiver will never discover. It's the sender who will discover by the timer. So because when every time the sender sends a frame, it starts a timer. If the time passes by without an acknowledgement, then the timer will go off. And that's how a frame is discovered. So if it's a 1 and only frame sent and it got lost, it will be discovered by the sender through the timer. If it's the one that's lost is 1 in a sequence, Like number 1, I sent you 1, 2, 3, 4, number 1 is lost. Your receiver received number 2, you see, where is number 1? And then you know number 1 is lost as a receiver. Sometimes, if the last frame is lost, let's say our window size is 5. I have to send you 5 frames, and I send you 5 frames, 1, 2, 3, 4, 5. But number 5 is lost. Number 5 is missing. So you only get 1, 2, 3, and 4. You don't know, maybe I did not send number 5. You didn't receive number 6. If the last frame is lost, nobody will know it's lost. But the receiver, when it receives 4 and finishes processing them, it will send acknowledgement. What's that acknowledgement? 5. It'll say, okay, I've received all the frames before 5. But if I was the sender, I'd say, hey, I sent you 5. I sent number 5. If you're sending me acknowledgement 5, that means maybe you didn't get it, maybe there is an error. I'll send it again. So the system will solve that problem as well. So this sliding window protocol, it works. It's a fantastic system. It's very efficient. And the main purpose for it is to slow down the fast sender. So if you have a real fast sender and the receiver can only accept 10 frames and say, okay, our window size 10. That means you can send as fast as you want. You can send them all in 1/1000th of a second, but you must wait until I process them and I send you back acknowledgement. So the fast sender will be slowed down. But the other way around, if the sender is really slow and the receiver is fast, the sliding window protocol will never get in the way. We'll get the sender to continue sending as fast as it can if it's slower than the receiver. So it's a kind of perfect system. It only pops up and does what it needs to do when it needs to be done. And if it doesn't need to be done, it will not affect the system or slow it down in any way. So it's an excellent system. And it has very little overheads and very little processing as such. Now, they have a name for it though. Let's say, again, another example. Let's take another example, take a larger window size. Let's say window size 6 this time. Here we go. So just in case you don't know what sequence numbers we'll send, that's window size 6 for you. So if the window size equals 6 and modulo 8, and if this is the sender and this is the receiver, the sender will send 6 frames from 0 till 5, 0, 1, 2, 3, 4, 5. And the sender is waiting to go to number 6. The next frame is going to be, the sender has actually a variable here. When it starts first, it puts 0. That's my next number to send. Once it sends you from 0 to 5, it updates it. Every time it sends 1 frame, it increments this number. So now it's 6. If sent 5 up number 5, the next frame I'm going to send you is going to be 6, unless something happens. So in fact, the sender has a pointer pointing at the next number. I'm going to send number 6 next. And the receiver also has a received number. When we start first, it's waiting to number 0. If it receives 0, it will go increment this to 1, 2, 3. If it receives all the way to 5, let's say the next one I'm expecting is number 6. And it'll send back acknowledgement 6 if all these frames are received correctly. And now the sender will send, like once we receive the acknowledgement 6, the window now moves to number 6, and there it is. The sender will send number 6, 7, 0, 1, 2, 3, and 4. 1, 2, 3, 4, 5, 6. Oh, that's 7. There. So we'll send 6, 7, 0, 1, 2, and 3. And it's waiting to now, the next one it's going to send is 4, if everything goes well. But let's say there's something wrong with number 7. So now, remember, the sender is going to send the next frame here, which is number 4. But if number 7 has an error, we'll send back acknowledgement. Acknowledgement 7. That means, hey, you sender, don't send me number 4 or whatever you were expecting to send. Go back to number 7. That's what the acknowledgement 7 means. Go back to number 7 and send me number 7. There's something wrong with number 7. And now the sender will have to send, remember, every time you receive an acknowledgement, the window moves to that acknowledgement. So now it's moved to number 7. So now I can send 7, 0, 1, 2, 3, and 4. 7, 0, 1, 2, 3, and 4. So just this is what they call this system now. Remember, the sender was about to go to number 4. It's just sent the last time here. It sent from 6 till 3. Sent 6, 7, 0, 1, 2, 3, and it's about to send number 4. But the receiver sent acknowledgement 7, which means go back to number 7 and start sending. So they call this system, based on this number and the acknowledgement, they call this go back N. Go back to this number. And that's what the acknowledgement actually means. Go back to this number and start sending. So this sliding window protocol is called the go back N. N means this number. And the number is that number in the acknowledgement. So even if you're a sender, you sent, maybe the window size is 100. You sent from 0 to 99. Now you're ready to send number 100. Sometimes the receiver says, no, go back to number 20 and start sending again. So this is what go back means. Go back to that number and start sending. Most of the time it won't. It'll tell you, okay, I got them all, send me the next one. But sometimes you might have to go back if you are a sender. And that's the name of this algorithm, go back in. Now, this has one disadvantage. This system has one disadvantage. I don't know if you are able to spot it, but let's say we agree we're using modulo 128. What does modulo 128 mean? Modulo 128, what does it mean? Pardon? So the sender will, and the receiver will use the numbers from 0 to 127 and then recycle them. When they get to number 128, go back to 0 and recycle the numbers. That's modulo 128. And let's say we decided to use window size equals 100. What's the definition of a window size? What's a window size? Is it the number of frames that the sender can send? The maximum number of frames that the sender is allowed to send. The maximum number of unacknowledged frames. The sender cannot send, he can send any less. So the window size, don't say the number of frames the sender will send. No, it's the maximum number they're allowed to send before having to stop and wait for an acknowledgement. Right. So this system, Bushra, what are the frame numbers that they'll be sent by this sender? I are eating. Anytime I ask somebody, they're eating. Yeah, what are the frame numbers, sequence numbers? Okay, start again. Next person. What are the sequence numbers that the sender will send now using modulo 128 and window size 100? Right. If you're unable to work this thing out, it's a definite exam question. Make sure you know how to work it out. So this guy will send 100 frames starting from number 0. So they'll send 0, 1, 2, 3, all the way to 98, 99. 100 frames, which is normal. Window size 100 is quite normal in network communication. So they'll be sending frames, one after the other. Remember, the receiver receives one at a time, there'll be maybe some of them stacked in the common device memory, but not in the device. The data link layer doesn't have memory, has only small amount of memory for the receiver, for one frame. It gets that frame, checks it. If it's good, send it to the user. If it's bad, discard it. Get the next one. Right, so we only have one space for one frame. But we get them all the time in sequence, and they're all good. If they're all good, we'll send back acknowledgement. What acknowledgement will we send back? If all frames are perfectly received from 0 to 99, we send back acknowledgement 100. That means acknowledgement 100. What does acknowledgement 100 mean?
Number of.
Thank you. Acknowledgement 100. What does it mean? We receive all the frames up until 99. Right? What about 100? That's what I expect from you, frame number 100. And then the sender will send number 100, 101, 102, all the way to 127, and then go back to 0, 1, 2, 3, until it sends another 100 frames. But there's something here wrong. Frame number 0 is wrong. The rest of them are all perfect. So what's going to happen now? What will this receiver do with frame number 0? Let's take one frame at a time. What will the receiver do with frame 0?
We'll send it back to.
We will not send frame 0 back. Well, maybe we'll send back acknowledgement. But what do we do with frame 0? It has an error. Discard. Discard. Get rid of it. It's no good. Discard it, right? And we send an acknowledgement to the sender. What do we tell the sender? Acknowledgement what? 0. That means everything before 0 is acknowledged, which is there's nothing before 0, or that's what I expect from you is number 0, or maybe it means number 0 has an error or got lost. But all in all, start sending, go back to number 0 and start sending. But we look in memory and we find another frame, that's number 1, it's perfect. What do we do with it? Send it to our user? What do you think? Yeah. Frame number 0 we discarded. Frame number 1, what do we do with it?
I will discard it.
Why would you discard it?
The previous one in the case.
It's out of sequence. Yeah, it's out of sequence frame. We're waiting on 0, we got number 1. Okay, see that 0 has a problem. We haven't received it yet, we're waiting on 0. So all these frames that are perfectly received, they've been transmitted. All other 99 frames are good frames, but what do we do with them? We discard them all. Why? Because they are not the correct sequence number we are waiting. We're waiting on 0, we got 1. And then we get waiting on 0, we got 2. So we get rid of them all, they're all discarded. But we've already launched an acknowledgement to the sender. Remember, the sender has all these frames, copies of all these frames. All 100 frames are there in its memory. So once it gets acknowledgement 0, it's waiting to go to 100. We say, no, go back to 0 and start sending again. So it go back to number 0 and send all these frames again, all the way to 98 and 99. And this time, they're all perfect. We got number 0. What do we do with number 0? This time it's perfect. Frame number 0 is correct. What do we do with it? Discard it? Send it to the user. Everything that's perfect in the right sequence, send it to the user. So send this to the user, this to the user. So the user is happy now. All 100 frames are received. We finished. There's nothing else there. What do we do? What does the receiver do now? We've received all 100 frames. We check them. They're all perfect. We sent them to our user. What do we do next? Send acknowledgement. You have to tell the sender, yeah, now all these frames are good. What's the acknowledgement number we send? Why 100? Because the last frame, the last perfect frame we received is number 99. Number 100, that means we're acknowledging 99 has been received. We have not received number 100, that's the one we are waiting for. This is normal operation. Now the sender will continue. We'll send the next 100 frames. You can get rid of, finally, of those copies that it actually sent us twice, except for frame 0. So can anybody see any little issue or a problem or inefficiency with this system?
Discarding frames that have no errors.
Yeah, we have lots of frames here all the frames, the 100 frames, just because number 0 has a problem, the rest of them have no problem, but we still discarded them because they are not the right sequence number. They are out of sequence, even though they were transmitted, and they could take a long time to be transmitted, to be checked for errors, and everything is perfect, and yet we still discard them, and they are resent again, retransmitted again. And that's not efficiency. That's duplication. You're actually using the channel not very efficiently. So this system has one little problem, is that inefficient use of the transmission channel. That's its only disadvantage. And it's not all the time, only if there is a frame with an error. Thankfully, it's not common occurrence, but still, it can happen sometimes if there is noise in the channel. So that's the problem with this system.
Is it inefficient using the channel?
Exactly, of the transmission channel. Inefficient use of the transmission channel. Or channel utilization, whatever. Any of those terms, anything that you explain that it means, hey, we're not using the channel very efficiently. We send good frames, we might have to send good frames again. So channel utilization is poor sometimes, or inefficient use of the channel. So they modified this protocol, slight modification. So I'm gonna look at this, and it's called anybody did a report on flow control? Right, let's go through the new system. Anybody knows what the new protocol is called? It's called selective reject or repeat. Selective repeat. That means we don't repeat every frame in the list. We selectively, we say repeat this. Or some textbooks call it selective reject. That means if you want to reject a frame and discard it, do it selectively. Don't discard the 100 frames like we did because the first one is bad. You will only reject the bad ones. So this is an improvement of the sliding window protocol. It's called, this is the selective repeat or the selective reject. What was the name of the previous one, the last sliding window protocol? It was called Go Back In. That's known as the Go Back In. Go back to number 10 and start retransmitting everything. This one never sends you back to a particular one and say send them all. Only send me that particular one. Now this is very simple, and it's pretty much the same idea with minute difference. So hopefully we should have no problem. It also, sender and receiver must agree on a window size and a modulo, and we use the timers and we keep copies. So let's start. This is the selective reject window size. Let's say, what window size shall we use? Any suggestions? 5. How about 5? And modulo 8. This is the sender, this is the receiver. So, okay, who's going to help me? The very back row there. What sequence number frames will be sent by the sender? What number do we always start with? 0. So we're going to send, okay, just in case if you don't know the window size, these are the sequence numbers, and this is, oh, I don't have window size 5. I have window size 4 there. But 5 will include this as well. So 0, 1, 2, 3, and 4. That's what we send. We send 5 frames, number 0, 1, 2, 3, and 4. Okay. If everything is received perfect, 0 is okay, it goes to the user, 1 to the user, 2, everything is fine. The receiver will send back acknowledgement. What acknowledgement will the receiver send back? Yeah, of course. Of course, don't forget that the sender must keep copies of those frames. Frame 0, 1, 2, 3, and 4, and must start a timer. Timer 0, timer 1, timer 2, up to timer 4. Now, we receive they're all received, sent to our user in the correct sequence. Now the acknowledgement we send is 5. What does acknowledgement 5 mean? It means 3 or 4 things. Give me one meaning to an acknowledgement number 5. What does acknowledgement 5 mean?
Received all the profile and
Thank you. We received all the frames up until number 4. They're all acknowledged correct. What else could it mean? Acknowledgement 5. I expect frame number 5 from you next. What else could it mean? Acknowledgement 5. It could mean, if you have sent me frame number 5, I'm telling you, it either has an error or it's lost. So either way, I want you to send me number 5. All these meanings mean telling the sender, start sending me from number 5 onwards. So now the sender will, after receiving the acknowledgement, it will clear memory, it will switch off all the timers, and will send the next few frames. Frame numbers? 5, 6, and 7. 8 and 9. What frame numbers will the sender send?
5, 6, 7, 0, 1.
Well, if we were using modulo 128, that would have been perfect, but we are not. Okay. Okay. Now, this is where we're going to start having little problems. Let's say 5 is okay, was received. Number 6 has an error. We found there's a bit error or damaged frame. They say damaged frame. Sometimes even the header is damaged. We don't even know what sequence number it is. But anyway, we got number 6, but has an error. So now, with the old system, we used to send an acknowledgement 6 and delete everything, start everything after that until we get number 6. But now with this new system, we don't send an acknowledgement. We send something called, it's called an ACK. Negative acknowledgement. N for negative, ACK for acknowledgement. That means, that's just to make it different from the acknowledgement we are used to. So we say, and this one, the negative acknowledgement is only for one frame only, not a group of frames. Only if we have 3 or 4 frames that have problem, we send a negative acknowledgement for each individual frame. And you have to give the exact number of that frame with the problem. So we have a problem with frame 6, we send an ACK 6, negative acknowledgement 6. That means we're telling you, Mr. Sender, we're having a problem with this frame. Please only send me this frame. So we only reject this frame. We don't reject number 7, the one after it, if there's nothing wrong with it. And you, sender, please send me another copy of number 6. So the sender gets this and starts sending the copy, but okay, it's in the way. We know number 6 is coming up. Now we look at number 7. Remember, these are coming into memory. Get the next one. Next one is number 7 is perfect. What do we do with it? Remember, number 5, we sent it to the user. Number 6 has an error. What did we do with it? Discard, right? Number 7 is perfect. We're not going to discard it. This is the new system. Can we send it to the user? No. We can't. If the user is watching a video, then you don't want to give him, a later kind of clip and then back again. Or listening to music. You don't want to give the back of the music, the end of the song before. So we can't send it to the user, but we cannot discard it. What do? We buffer it, we store it. Buffer means keep it in your memory. So now, this system, the receiver reads memory. Anybody knows how much memory we will need? Just think about it, we'll get to it. Just think how much memory does the receiver need. But number 7 is fine, that means we have to keep it here, buffer it. We can't send it to our user, but we're not going to get rid of it. Now, we got number 0. Number 0 also has an error. So what do we do? Any idea? send another NAC. What number in that NAC? 0. So the NAC is very specific for one frame. That frame has a problem. So when the receiver receives that, will send us back number 0. So number 6 is being sent here, followed by 6 is almost going to get there, and followed by a 0. So it's on the way, but we haven't got to it yet. We got number 1. Number 1 is perfect. There's nothing wrong with it. We checked it, has no errors, everything is good, correct size. What do we do with that? Number 1? Buffer it, keep it. You do not discard it. It's a good frame. It's not for discarding, but it's not to be sent to the user yet. It's the wrong sequence. The last good frame we sent to the user is number 5. We can only send number 6 and then followed by 7, 0, and 1 to the user. So we buffered this one. So we buffered 2 frames, number 7 and number 1, and we are waiting on number 6 and number 0. So now our receiver would have, our sender would have received the NAC 6 and would have sent us frame 6. So that's what we will get next, 6. Let's say this time is perfect. There's nothing wrong with number 6 second time. So what do we do with it? It's the next in sequence to be sent to the receiver. So we send it to the user. To the receiver, because the last frame we sent to the receiver is number 5. Now we send it number 6. And we already have number 7 already stored in our memory, so we'll follow it up with number 7. See, they're all going in the correct sequence to our user. Now, imagine if we, at this stage here, we received number 0, and we checked it and it's perfect. Now we have number 1, we cannot send number 1, but his 0 came and it's good, so we'll follow it with number 0, and now finally we send number 1. So as you can see, they went to our user in the correct sequence, upward, 5, 6, 7, 0, and 1. Finally, once they're all received, now we can send acknowledgement, not negative acknowledgement. What acknowledgement shall we send now? Any acknowledgement number, any suggestion? Okay, the last frame we sent to our user is number 1. That means 2, because 2 means we have already received number 1. So this is how the selective reject works. And you need to be able to go through this. If you're given an example, they say you're sending 5 frames, window size shots and shots, and frame number 3 is lost. How would selective reject, show the operation of the selective reject? So you start going and, okay, let's get an example, an exam question or a test question in an exam. This is now selective reject. So what's the advantage of this over the go back in? This one, any frame you send, if it's a good frame, we don't retransmit it. Remember with the last one? Like imagine if we're doing selective reject just to show that it's better than the last system. Imagine if we are using window size equals 100. So this one sends frames 0, 1, 2, 3, all the way to 98, 99. 100 frames are sent. Imagine if 0 is bad, has an error, but 1, 2, 3, all the way to 99 are good. How does this system work? What do we do with frame 0? Any idea? In the selective reject. This one, discard. What about number 1? Can we send it to the user?
No,
discard it?
Buffer it.
Buffer it. So just store these or buffer them. All of them, 1, 2, 3, they're all out of sequence. And we send back what? NAC 0. And then hopefully when the sender sends us frame number 0, and it's good, we'll send it to the user and then follow all the stored ones and follow them to our user. And this way we did not retransmit the 99 frames like we did with the previous system. And this one has better utilization of the transmission channel. Yeah.
It's gonna keep all the storage ones until it receives the actual acknowledgement.
Well, not millions of them. There's always limited by something. Now, that's why I was asking earlier on, how much memory do you think we need?
window size -1 frame.
Okay, good. Perfect. Like, I mean, did you do this course before?
No. I mean, it makes sense if only one, if the first one is an error, we keep all them.
Yeah, now you understand it. You're happy, you know? Yeah. Because we have number 5 and number 6 was bad, we got number 6 and now it's good. And we sent number 7 to our user, and then we had a problem with number 0, we got number 0, and then number 1 we already had it, and now we send it to our user. So our user got all the frames up until number 1. So what the acknowledgement to send? 2. You always give the next number, you don't want the one that we have not received. Because when you say 2, that means we have received 1, which we have received 1. If you say 1, no, that's we've already received it. Okay? Okay, guys? So this works perfect from, it never retransmits a good frame because the user is going to keep it. But what's the problem with that? The problem, the receiver now needs memory. So it needs to be able to store these frames that are out of sequence. Remember, the maximum, let's say whatever the window size, 100, that means we'll be sending 100 frames. The worst case, this is the worst case I'm showing you, if the first frame is bad, of course we don't keep a bad frame, we discard it, but we must keep the rest of them. So the worst case, you need as much memory as you can store as many frames as window size -1. How much memory does the sender need? Anybody knows how much memory does the sender need? How much memory do you think the sending machine requires in either selective reject or go back in? It's the same amount of memory. What do you think? Does the sender need to keep something in memory?
Copy of the frame.
Copy of all the frames. How many?
Same as the window size.
The same as the window size. So the sender always, if you're asked, compare the memory requirements between the sender and the receiver. It's say in the selective reject. The sender will need as many as the window size, agreed window size. So if we say window size 5, that means the sender must be able to keep 5 frames, send them, and keep copies of them. But the receiver, how much memory does the receiver need? It will never need 5 because, you know, the worst, maybe the last frame is bad. So if it gets 1, 2, 3, 4, send it to the user. We don't even need to keep them in memory. But if we get number 2 is bad, 1 will be sent to the user, 2 is discarded, 3 we cannot send to the user. It's good, so we keep it. So we only keep the frames after the bad frame. And the worst situation is if your first frame is bad, you have to keep the rest of them. So it's the window size -1 is the requirement for the receiver. As much memory as it needs to store as many frames as the window size -1. It depends now on the frame size. If you want to calculate it exactly, if I tell you, we agree the maximum frame size is 1000 bytes. The window is 10. How much memory do we need? The sender will need 10,000 bytes and the receiver will need 9,000 bytes. Right? Is everybody okay on that? So this is the second system. So which is better? The go back in or the selective reject? Selective repeat is a good answer. But it's not the right answer. Which one is better? Go back in or selective reject? It depends. It depends on what? Yes, this is the answer. It depends, but it depends on what? Which one is better, selective reject or go back in? What do you think? It depends on memory, yeah? Which one is better? Okay, the selective reject has a problem, it needs memory. The go back in needs less memory. So that's one major difference between them. So if we are worried about memory, use the go back end, it's better. It doesn't need as much memory at the receiver end. On the other hand, why do you think the selective reject is better?
Certifies the channel transmission.
Say again?
That it doesn't keep occupying the transmission channel, the communication channel.
Yeah, so from a channel utilization point of view, the selective reject is better. From memory requirement, the go back end is better. So that's why you can't say one of them is better than the other. One needs a lot more memory than the other. Memory is not a cheap thing, at least it wasn't over the last 20 years. It's always been expensive and technologically difficult to increase. It's getting a little bit easier now and cheaper, but yeah.
This selective repeat is very, in this case, does not occupy the channel. If you have a big window size, right? If you have a lower window size, the other system is more or less the same. Because you're not going to send as much frame.
It depends on the error, how good the transmission channel is. If we have a high rate of errors, that means we're getting a lot of errors, then you'll notice the go back end is always retransmitting good frames. But if the channel is good, you probably will never need to retransmit. So, which of those do you think is in use in networks? In fact, the older system is in use because they started with it and it's implemented on almost every network in the world. It's a very famous algorithm, the Go Back Sliding Window Protocol, and the improvement probably is not as much, and now the transmitters and receivers are getting better and better every year. So instead of we used to get an error every 1,000 bytes, now we get an error, and then they became one error every 1,000,000 bytes, now one error every 1,000,000,000 bytes. So the rate of error is decreasing all the time. Our transmitters and receivers are getting much better, we're getting less errors, and therefore that problem is really not, it's better to use a better, channel utilization, but to change it, it will cost so much in so many computers, so many network cards. It's already imprinted in the network cards. That means you have to change a huge amount of infrastructure or hardware that it's not worth it. So there are a lot of, just like the parity error detection system. It's a bad system, but it's still probably the most commonly used other than CRC. Like it's ingrained into every hard disk and every storage device and every communication, even though it's not really a great system. It has many errors. Do you remember what errors it cannot discover? The parity system.
Have even number of bits swapped in the same message.
No, not in
It's the same frame.
No, not the same frame or packet or file. In the same byte, in one byte. Okay, just hopefully you remember this in a test or an exam. So it's all right. That's right. Sorry, you have a question.
Yeah, so if the device it's hardwired to do the selective repeat protocol, then, or at least the network is connected to it, and it sends the bit or the frames to a computer that doesn't have enough memory to store that amount.
Never before they start, they must use, in all communication, both devices must use the same protocol. Like in error detection, you can't say I'm sending you a message, I'm using the parity system, and you say I'm not using the parity system, I'm using CRC. We cannot communicate.
So
we must all agree on the same protocols.
A network uses sliding window.
Yeah, no, well, no, it cannot communicate. The other way, yes, but if we don't have memory. Yeah. All right, now, I have another little issue here. Imagine again, we're using, I will continue with this. Window size, guys, 100. I've sent you 100 frames, from 0 to 99. You send me back acknowledgement, 100. Perfect. Now, here's the acknowledgement 100. Whether we are using this protocol or the other protocol. What frames will the sender send now after receiving acknowledgement 100, if our window size is 100? Who's going to help me there? Anybody on that end? Any volunteers? Oh, you're volunteering, great. Thank you for volunteering. What's the sequence numbers the sender will send? I got acknowledgement 100. What frames will we send? 100, 101, 102, until 199, let's say. Okay? Because the window size is 100. We're gonna send 100 frames. Mamma mia. But of course, not 199, because we're using modulo 128. So when we go to 128, we go back to 0, 1, 2, 3, 4, 5. So I don't know, whatever, it's going to be 69 or 79. Okay, maybe it's 79. Okay, to reduce complexity, let's say we start again. This guy sends from 0, 1, all the way to 99. And this guy sends back acknowledgement. Sorry. Nice. I want to give a better example. Modulo 128, that means we're using the sequence numbers from 0 to 128, but the window size is 10. All right, so the sender sends 0, 1, 2, all the way to 9, 10 frames. We just started communicating. Now sometimes, what are we expecting? Either with either system, they're all received correctly. What acknowledgement we should get back? 10. But imagine if somebody here sent back acknowledgement 80, which is still, we are on modulo 128. So if you send somebody 10 frames, and they turn back and say, thank you, I've received number 79, can you send me number 80 now? You say, hold on, there's something wrong. You can't expect, like a receiver telling you, I've received frames from you that you never sent. This kind of error cannot be fixed by retransmission. You can't say, okay, can you send back, I'll send back the same frames. It's not gonna fix the problem. The receiver thinks you sent them 80 frames when you only sent 10 frames. There is a range, an acceptable range in the acknowledgement number. What is the acceptable range? What numbers will still be okay, normal operation, even if there is an error? Like what we should expect number 10, that's the largest number. Nothing, if they say, hey, I'm waiting for 11, I say, oh, that means you got number 10, I didn't send you 10, there's a problem there. But so 10 is the largest number we will accept. But what's the smallest number we'll accept? If the guy sends you acknowledgement 9, is that okay? Does that mean anything? Yep. It means frame number 9 has a problem, so I can go back and send 9, right? What if they send number 7? That's still okay. Yeah. Number 2, okay. 0, okay. Anything before 0.
It's plus or less the window size.
So it's the window size, whatever the window size. Outside the, okay, even previous ones, they'll be duplicates. We can forget about them. But anything higher, that's really a bad mistake. That means I don't think we can continue. We have a problem they call synchronization problem. There's no more confidence or trust. I'm sending you 10 frames, you say, thank you, I received 70 frames from you. No way. So we know then, either the sender or the receiver will know there's a problem. So whoever, sometimes he send me acknowledgement 10, and that's the right one, but instead of sending you number 11, I send you number 101. I say, wait, you're sending me the wrong frame. You only sent me 10 frames, now you skipped 90 of them. So the problem can happen by the sender, sending the wrong frames completely, or by the receiver, sending the wrong acknowledgement completely. And this kind of error cannot be fixed by retransmitting the missing frames or the error frames. And in this case, we really have a problem with our communication, and we should notify our users, and we should cancel all the communication. And they call this, it requires link reset. So there are some errors that cannot be fixed by retransmission, and they require a link reset. That means, A, there's a problem between you and I at our level, at the data link level. Our users don't know, so we're gonna notify our users. This is like us losing the communication completely. We're gonna reset everything. So what does the link reset process? We know now what causes it. What will cause two systems to decide, one of them decides to reset the link. And if one of them decides to reset the link, the sender or the receiver, the other one cannot say no. The protocol says you must continue with the link reset. We must clear the air between us and start communicating again. Hopefully the second time things will work. So what does the link process entails? The following steps. First, if you have any frames in memory, either send or clear memory. Clear all memory. This is the first step we do. Everything is going to be deleted. And all the variables that we have, the counters, how many frames did you send me, frame number 10, what acknowledgement we send you, what frame I'm expecting, zeroize all counters. Zeroize all counters. That means reset, put everything back to 0. All counters, that means what, what frame number did you send you, what one expect from you. And so basically we're canceling everything. We're clearing our memory. There is a problem between us and we need to start again. And we need to tell, okay, turn off all timers, reset, or turn off all timers, turn off all timers. And variables and counters. And tell our user up there, we lost the link. There's a problem with the link. Notify, usually we notify the network layer. So if the network layer was transmitting something, it will have to tell the user up at the top. But we tell higher levels, notify the user. Because our user is really the network layer, if we're at the data link layer. But this protocol is also used at the network layer. That means notifies the transport layer. This protocol is actually used also at the transport layer. I'm telling you, it's the most used protocol, sliding window protocol. So it's used at the transport layer, and that then will notify all users. Like sometimes you're downloading a file or a video, and sometimes you get a note. Sorry, we lost the internet. That's the physical layer, lost the internet, told the data link layer, told the network layer. So now they notify you on the screen. But this one, we did not lose the internet, but we lost confidence in the other machine we're downloading the file from. So, but anyway, we notify the user that the link is reset, link reset. What does that mean? It means forget about anything we were transmitting. If you were downloading a file, a video, and maybe you went 80%, 90%, and then that's it, we told you we lost the link. It's like we lost the internet. When you start again, do you start uploading again or downloading the full file again?
No.
It depends on the application, depends on your programmer at that level. Some programmers, if you write a program, for example, and you're downloading a file, there are two ways to do it. Just download it, store it in the hard disk. If you lose the internet, that's it, you have no information. When you start again, you have to start downloading again, because you don't know how much you've downloaded. But some programmers, what they do when they are downloading, usually you write the two programs. You write the program here and the program there. So they say, all right, I'm sending you whatever, I've received 10,000 bytes, 20, 30, 40, 50, 93, 780, and then the link was disconnected. Now I keep a log. The last time I was downloading this file, I got 9,000 or 93,428. If we link again, I check my log, I say, oh, the last time I was downloading this file, let me link with that application again, and say, please, can you go to this point and start downloading from that point? But that's the application up there. Some programmers are good, some programmers are not good. But as far as we're concerned, we're at the data link, we just tell you it's disconnected, and whenever we set it up again, we'll tell you it's back again. It's up to you whether your program is one of the good ones or the bad ones. But as far as we're concerned, it's like you losing the internet and then got it back again. If you have a good application, they'll continue. If you have a bad programmer, they will start from the beginning. But that's not our issue. Our issue, we just tell you, we lost the link. So we lost the link, we reset everything, put everything back to 0, and then we have to do parameter negotiation. Parameters negotiation. So we need to negotiate our parameters. Parameters, that means the variables that we are using. Like, what modular are we going to be using? We're going to start the link again. But what modular should we use? What window size should we use? Some examples. Maybe modulo. Window size. What else? Usually maximum frame size. Retransmission timer. Usually there's default value, but these are the variables that you and I need to agree on, the sender and the receiver. Retransmission timer. And do you know that this thing, for example, if I send you a frame and it got lost, my timer will go off. So I send it again. If it got lost, or I didn't hear from you. Maybe you got it, you sent the acknowledgement, I didn't get the acknowledgement. My timer goes off again. I send it again. My timer goes off again. There is actually a variable to how many number of retransmissions that we will do. And then after that, we call it the day. We say, hey, there's a problem with the link that we have. So that's another variable. There's a long list of variables that they are agreed. It's called number of retransmissions. Number of retransmit. So once we agree on these, so usually I send you one value for each. I want this module, I want this window size, I want this, or this frame size. And when you join a network, you should only join a network if you can use a range of those variables. But if the two of you disagree, the network says then you must use this value. So there's a default value. For each one of those, there is a default value. If I want to use window size 70, you want to use window size 20, we disagree. One negotiation. If we don't pick the same values, well then we refer to the network default, whatever the network default value, and we have to both use it. You won't be allowed to join the network unless you can at least do the default values. Anyway, so these are all sent. And finally, we send, that's it, one last thing we're going to do, and that's exchange a frame called receiver ready. That means we're ready to communicate again. And what's the receiver ready? It's just like an acknowledgement. It's an acknowledgement 0. So once we agree on all these numbers, we clear our memory, we want to start again, we must send each other acknowledgement 0. What does acknowledgement 0 mean? So acknowledgement 0 has one more meaning. It means everything before 0 is received. It means that's the next frame I expect to receive from you is number 0. It could mean maybe 0 if you sent it to me, it's lost. But now it means one other thing. After setting up a link, the receiver is ready. I'm ready to start communicating with you. It's called receiver ready. And that's it. And then we go back again and we continue. So this is the reset process. You are asked what's the reset process? And why do we need to do a reset process? If we get errors that cannot be fixed by the transmission. See you tomorrow or no? It's today Friday.
Tomorrow.
See you next week. Guys, there is a class test on, I think it's the 6th of December, Tuesday, 6th of December. So we have class test, so be careful. Study for it.
So,